Step number three, task selection. This is my favorite one. I'm going to be honest. This is my favorite one. Oh, why? I spent, honestly, years of research learning about tasks and how they work. So that's why this is my favorite one. I'm just going to be honest. Task selection. All right, that was kind of whack. Anyway, let me give you all the formulaic definition. A mathematical task is defined as a mathematical problem or set of problems that address a related mathematical idea or concept. I put references in here because I'm an educator. Stein, Smith, Hennessy, and Silver 2000. A mathematical task is defined as a mathematical problem set. The reason you have to be intentional when it comes to task selection, because the task kind of dictates the quality of the lesson that you're going to have. You need to make sure when you're teaching math, you get high cognitive demand tasks. I'm going to say, simplified, rich problem solving tasks. You want to provide opportunities for children to think. You don't want them around here guessing and trying to figure it out. You want to use high quality tasks, rich problem solving tasks. That's the key when it comes to mathematics task selection, okay? So now, when I'm selecting my tasks, I want to make sure children are doing the thinking. Here's a simple thing that I've said before, said in the past. Some of my OGs know this one. Some of my new folks like, what does this mean? But I love it. If Siri can solve the task is too easy. Right now, you all have even Chat GPT. You can put that one to the side. It's coming up. I'm going to do a mixtape series on that. But for now, if Siri can solve the task, or if you use Alexa, the task is too simple. Why? They're always going to have Siri. They're always going to have Alexa. So why give them tasks that are basic computations? Give them tasks that require them to think and make sense of what is happening. When you're using high quality instructional materials, guess what? They're already within there. They're already in there, these good tasks. The problem with I'm going to just be honest. A lot of folks think because they have more tasks, the curriculum materials are better, when in actuality, I'm going to give y'all a secret. You know how publishers put so many tasks in there? Like, what I mean tasks. Why do you have like 50 problems for one lesson? Let me tell you why. Secret. It sells better. Oh, why? Because when you do the flip test, you open a book. Shout out to high school mathematics. This is not a math textbook. I'm not promoting anybody's material, but this is just from NCTM, so it's a great reference book. But what happens is when you have a bunch of problems in the book, people open, oh my gosh, I'm teaching fractions. Look at all these problems to choose from. And people buy the book. But in reality, you don't need 50 problems to teach a standard. You don't. But they put all that junk in there because it sells better, and you all say it's a great book. So what I recommend highly, you have to be critical when task selection. Now, just because you have high quality instructional materials does not mean all the tasks are good. Typically, the formula that most publishers use in the very beginning, what they do, rote routine, quick problems, they do, but after you warm up, just some quick computations, then they get in some more involved, and at the very end, they have the higher order thinking problems. I recommend you reverse engineer it. Look at those higher order thinking problems first, and you probably want to start that task. Less tasks, greater depth. You don't need a bunch of tasks to unpack a standard, to make sense of the standard, or to align what you're doing to the standard. You don't need a lot of tasks. What I highly, highly recommend, look at those higher order thinking questions first, typically your word problems. You work through them. See if they align to your student learning outcome. If they do, then guess what? I would start with those, because if a child or if your class can do well in the high order thinking tasks, those rich problem solving tasks, they can do the rote routine tasks. But oftentimes we start the rote routine task and we don't even have time for the high order thinking task. So reverse engineer it. When you do that, guess what? You give them an opportunity to showcase what they know. Less tasks. And again, I understand the books look beautiful, but again, you don't need that many tasks. And if you really look through those 50 problems, I'm gonna be honest, maybe 10 of them are actually even quality, because a lot of them are just, I'm not even gonna tell y'all how they make those tasks, but a lot of them are trash. Just being honest. A lot of them are trash. Like the materials overall are good, but when it comes to lessons, trash. But task selection, why is that key? So here, I'm gonna give you two examples. Here's the first example. If I look at that standard and I look at that student learning outcome, this task right here can get me there. Just says solve 362 plus 354. But what I say earlier, if Siri can solve the task, it's too easy. So while this task will align, while it checks the box, how much thinking goes within it? And it's bigger than can we get to the algorithm? And understand, I know some folks fluently, Chris, they got to do it fast. No, fluently does not mean fast. It means efficient with strategies. So it's not about can they get this answer fast, and how often they're going to, somebody come up to them, hey, buddy, got a quick question for you. What's your question? What is 362 plus 354? How often do you get that question? If you do get that question, you're going to have a calculating device with you. Again, this is what we call low-level tasks. What I recommend is a task like this to start with. Within this particular task, still grade 3, check it out. 3 students find the value of 362 plus 354. Their work is shown. Explain how each method works. Imagine the great discussions that we can have with a task like this. Oh my gosh. Oh my gosh. I love this task. I love this task. Why do I love this task? Look at it. It's so simple. It's so cool. And there's so much thinking goes involved. In the very first one, they're using manipulatives. And guess what? I'm putting out manipulatives. Year round, when I'm working with children, I have manipulatives out for them to use. So here I got manipulatives put out. In the second one, oh my gosh, look at that. They're making tens, they're making hundreds. I'm not getting to the depth of it. But I love that second one when you think about Lynn's method. And then you get to the standard algorithm over in the following column. The last column. Slipping my words. That's why I like that one. Why is this key and critical? Because there's a lot of problem solving thinking. You got expanded notation when you look at 300 plus 60. I told y'all what it was. But you get what I'm saying. It's a rich problem solving task. Going to give a lot of opportunities to dive into the math. Still aligned to the student learning outcome, which is aligned to that standard. Boom, I got a better task than just, hey, let's add 2 numbers within 1,000. Here are my closing thoughts with step number 3. Strategies are greater than memorization. Strategies are greater than memorization. It's not about can they memorize. It's all about do they have strategies. Less task, greater depth. Less task, greater depth. Less task, greater depth. What does that mean, Dr. Childs, in case I don't know? If I use less tasks, like the task I just showed you all, I can use going to greater depth of understanding as opposed to quick. Children are not like, all right, oh man, it just came to me. Children learning math are like popcorn in a bag. What do you mean, Dr. Childs? Oh, I'm about to kill y'all with this example I'm about to do. If you've ever popped popcorn, it tells you how long you need to pop it for, right? As you're hearing it, some kernels pop early, some pop late, but over time they pop. And have you ever noticed when you get to the end, you shake the bag, sometimes, depending upon the bag, every kernel hasn't popped. What do? You put it back in for some more time. Pop, 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 pop. Some more pop. That's how teaching math is. Some are going to pop early. Some are going to pop late. The key is if you give them more time, they're going to all pop. Just in their due time, give them time to pop. Hey, don't take that one. You got to credit Dr. Childs. They're like popcorn. And if you're patient enough to wait on popcorn to pop, and think about popcorn, yes, it's fun, it's great, and it's always, popcorn is almost endless. If you're patient to wait on that popcorn, why can't you be patient for the children in your class to pop, 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 pop. Oh man, step 3, that was smooth. Let's get ready for step 4.